Yeah. So today's daily challenge problem is alternating groups 2. So basically, what they have asked is so there is the input consists of a circular array where each cell of each element in the array is either colored blue or red, and they have given they have given this circular array called colors, and that's an integer k. Now they want the question is we need to find the consecutive elements, k elements, which are alternating in color. So if I take this as an example, uh, this 1 and 2 are the subarray consisting of 1 and 2 here is a subarray of size 2 and meets the is suitable because the consecutive elements are of alternate colors. So the consecutive like 0 1 2 is a subarray where the elements which, like, basically if you have considered one element into that array, then this neighboring element should be of opposite color, and this applies only for the elements which are starting from the second position and the last but one position. Okay. And for the so for the first position it should be opposite of the right side of the right side of its the color which is right to it, and the last position's color should be opposite of the color which is left to it. So now we need to find how many such sub arrays of length k are existing in the circular array, which suits the alternating color rule. So in this example, if you see, uh, like, so they have given an example and they have told that like 0 1 2 is an array. Basically they want a sub array size as 3, and that should be like this is one array and this is 1 2 3 is another one, 2 3 4 is another one. Now 3 4 0 can't be another one because 0 and 4 have same elements and they are beside each other. So let's see the main cases, like how we will solve this. So let's say this is our example, and now this is the linearized circular linearized form of the circular array. Now after observing this question, we'll come to a conclusion of one thing, that if, let's say, we have I know the max sub array size where the color is alternating. If I want to increase the sub array size by one position again, it can't be alternative because either at the left or the right side they are the colors are matching, they are not alternating. So what happens is, let's say the array is 1 0 1 0 1 0 and 0 0 here, and coming at the beginning it will be 1 1 here. So let me say this is the array position. How can I mark it? Yeah. Oh, okay. So I can't mark, I guess. So let's say the array which I am considering is starting from 1 0 1. This is the biggest array because I can't exceed here because these two will match 1 and 1, and here 0 and 0 match. So this is the highlighted one is the biggest subarray which matches the condition. Now what would be the answer of this? Let's say k is equals to 2 here. Now what would be the answer? The answer would be like of one subarray of size 2 starting from this position, and next like it becomes 0 and 1, and next subarray starting from 0 position, and so on. So if I just draw over here, so this will be our first array. Oh. So this will be a first array, this will be a second array, this will be a third array, and this will be a fourth array, this will be a fifth array. So what happened here? Now n is what? So k was 2, and the subarray length was how much? 1 2 3 4 5 6. So subarray size was 6 and k was 2. So we need to find a formula how to find the number of subarray is possible with size some size, let's say 2, and the total length of the suitable alternating color. So the total number length is 6, and now we have like length of the subarray is required is 2. Now we need to find how much it is. While dry running it, we can easily say it's 1 2 3 4 5, but the suitable the number of subarrays would be, let's say the length is L. Now we need to, like, if we observe here, each subarray starts at some point. So first can start at this point, next at this and this and this, until we reach at some point where the last two characters are no more alternating. So this is the last index where I can start the suitable subarray. So how that, then according to that, then I need to subtract whatever was the length of the subarray we are taking, and also I need to add 1 because to match the count. So basically we exclude one from here at the last, so we need to add 1. So according to this, so if I just substitute L is 6, and then it is 2 minus 2 and plus 1, so it's how much is, it's 5, and it's 2 1 2 3 4 5. So this is for the linear case. Now what about the next, what about the circular case? Circular case will work same as this in such conditions where there are some neighbors, there is a left, like apart from this length, the left one is matching with the leftmost element here, and the right one is matching with the rightmost element here. So there may be some like multiple subarrays for in this scenario. Like I just shown one example. Now it would be like 0 1 1 0 0 1. So here again we need to calculate this also. So as we calculated here, we need to do it the same way for here, and we need to just sum up all those answers. So yeah, this is one case. Now the interesting part here is now, so the answer for this such kind of arrays where there exist, like we are ensuring, right, there exists at least one place where two cells which are neighboring each other are having same color. That time this logic works. But what about the circular array, like circular way where each and every color is alternating? So before going to that solution, the solution for this such cases is, even if it is a circular array, the same logic holds because of at least one neighbor having same color as its another neighbor. So if you see, the answer for this would be, let's take this example. So the answer would be, say, let's say k is 2 over here, so it would be, so 1 and 2 3 4, so answer is 4. And what if k is 3? So k is 3, then this can't be a subarray, valid subarray. This can't be a valid subarray. This can be a valid subarray. And 1 is the subarray. Let me give a counter 1 and 2. So, and what about next? 3, not possible. So basically there are two valid subarrays here. So the answer here is 2. And that we can do it like, why in code it's easier to track the number of, so basically what we are tracking is the number of changes happening between the neighboring colors. So that will track, while iterating over this circular subarray, we will track the number of color changes. And if there are like let's say I'm starting with here, the number of change is still 0, like let me say I'm starting at index 0, and I'm also taking the start index for such kind of case cleverly that the previous element is not different than the current element. So I'll start iterating from a case where previous element is always same as the current element. So in this case, this is easy because I can just check, I can keep track of an index. So basically I will keep a variable over here, index initialized to 0, and I'll check if 0's previous color is matching with this. If it is, then my index will be the same thing, and I'll break out the loop. In this case it is the same, so it is easier. Let's say if it was not matching, and let me say I came to here over here, so 1 is not matching with 0, again next 2 is matching with 1, so my index in that case would be 2, and I will break out of the loop, storing my index in a variable for further use. For further use, it's like I will be starting my iteration again from second element, from this element, and then to like next I will be just tracking the changes over here. Why I don't want to do from midway? Because I want the maximum count of the subarray. Now if you observe here, I just mentioned that the neighboring color should be matching, so I want to take the maximum subarray as possible as I can, and that can be done while starting from a place whose previous element has the same color. So yeah, so hope the logic is understandable. And now basically at the end, our main goal was to count the number of changes. So the change for like number of changes, store it into vector, and then compute the answer based on this formula. So the number of change, let me say I have started, because the index was matching suitable for 0, the changes would be like this. So let me say my answer vector is like, let me say changes is the vector list basically. So I'm just keeping a track of changes over here. So let me say I have started over 0 and its previous element is same, so number of changes is 0. It will be pushed back, it will be added into a list. I will go to next element. So the color is changed. I will keep the counter, track of a counter. Initially count was 0, now it has changed, it was 0, so now it will become to 1 because the color has changed. I'll come again in my next iteration, I will come over here, the color has become same, so I will push the counter, and I'll reset my counter to 0. Now I'll come to my third position, the color has changed, my counter will be incremented. Now I'll come to my fourth position, the color has changed, the counter will be incremented. Now I'll come to my fifth position, the color has changed, the counter will be incremented. Now I'll come to my okay, this is done. I have already processed from index 0. So my finally, after exiting from the loop, we push the whatever counter value is there in the changes. So yeah, we do that, and this is the array. So here like this is each of the L values basically. So what you do is you just, answer would be like this, answer equals max of, we are taking max of 0 just because something shouldn't add to as a negative. So max of this, L is what? L is some Li, like whatever is the like changes of I, basically changes of I, and minus k plus 1. Okay, this works. So then just return the answer. This is fine, provided the observation we made that we want the longest subarray which is alternating, which only is possible if the element previous to the first element is same color. What if the circular array had completely alternating colors at every position? So let's go to that case. So in this case, if I can see each and every color is alternating, and now we can't apply the same logic as we applied over here. In this case, the answer for the linear array and for the circular array will remain same. but in this case it's not that. So why isn't it? Let me say I have taken k as value 3. In k, I will just draw the k value 3 possibilities of the answer. So if k is 3, then this is possible, this is possible, and yeah, those are only two possibilities. But what if we come over here? So first of all, you need to understand why only two possibilities are there. It's because we could only stretch this much forward, and we couldn't this end. If this ending position started ending at this, basically this came over here and this came over here, basically like the next one, like this way, it won't be a valid. So we need to limit over here, and but in this case what happens is we have a limitless option. The size of the like k value doesn't depend over here, because we can reuse the previously used elements which are alternating. So what I mean by that is, let me say my k is 2, so this would be in my linear array. If it was my linear array, I could use this, I could use this, I could use this, I could use this, I could use this. So how many elements? 1 2 3 4 5. 5 is the answer. But because it's a circular, we can use the next element over here, which was red. Basically this is the one which is coming over there, like this is 0 basically over here, because it's circular. This is the same thing as this. So there would be an additional subarray which would be this, and that will increase our answer. So what happens is, if I move, let me erase this. So if I want to show it in a circular way, it would be 1 2 3 4 5 6. So basically what happens is, each and every element, each subarray of length k will start from each of the positions. So if you see, this is starting from 0, this is starting from 1 2 3 4, and so on. So yeah, so in this case it's the formula is not exactly this. Why? Because we are able to use the first elements, because it's a circular array. So what would be the formula? Let me just guess. Because we are there is a because there is a valid subarray starting from each and every position, then that makes sense that the answer would be just the size of the array, the size of the circular array, which is n, which is given in like basically the options input array size. So let's see the code out of it just quickly. So basically how do we identify this is this is the case of the input, because we were just we can tell it by the changes. So basically if changes count has reached n minus 1, because we are just iterating over this and we are checking number of changes would be always n minus 1 in such case. So we'll just check it. So yeah, this is the code. What happens is, we initially, as I mentioned, I want to find an index whose previous index color, previous element is same as the current element color. So I'm just checking to get such index. I'll store it and I'll break, because in our example 0 was itself finding it like matching this case, then index would be 0 over here. So yeah, coming to this part, changes is the like the subarray is the number of alternating colors basically in a like the max subarray length of alternating colors in a max possible subarray of alternating colors. So yeah, initially count is 0 and we are checking if previous this color didn't match with the current color, then we are incrementing it, and we are pushing it back. So yeah, this will only track the number of changes. This will track, basically increment the counter whenever the color is not matching. By this it means that it's tracking the number of color changes, and whenever there is no color change, we just push it in the store that data and then reset the counter. And the edge case which we discussed over here, we wanted to make sure that if number of changes is n, then return n. Okay, so why number of changes is n? Because we are checking for each and every position if it was not matching with the previous position. So there are total n positions, so we will do n checks, so counter will be incremented n times. That's why this is the case. I just didn't explain it properly over here. I just said n minus 1 times it, the number of the counter should be, but yeah, it should be n times. So if it is n times, just directly return n, otherwise use that formula length size, which is strip plus 1, basically. Yeah, strip plus 1. So like strip is the number of changes, like changes plus 1, because subarray would be changes plus 1. Number of changes would be always 1 lesser than the subarray size, minus k plus 1. Yeah, and yeah, just adding it to the answer, and we just return the answer. So yeah, this is the solution for it. I hope you got, I have just made a syntax error over here, but yeah, I hope you got the idea behind it, and I think this video would be helpful for you. Thank you.